Hello students, in this video we'll prove monotonicity formulas for the convergence of an infinite continued fraction. If we're given a0, a1, a2 forever, the nth convergent is c sub n, and it's Pn over Qn. So what we're going to need for this problem is we're going to need to recall the recursion formulas for P and Q. So we know that Pn is equal to an Pn minus 1 plus Pn minus 2, and Qn from a previous video is an Qn minus 1 plus Qn minus 2. Now we have the following result. If I look at Pn minus 1 times Qn with a minus sign and plus Pn and then a Qn minus 1, if I look at this combination over here, then this combination can be written as I claim that this is going to be negative 1 to the n minus 1. So let's see why that's the case. Well, if I write this, this is going to be negative Pn minus 1 times an Qn minus 1 plus Qn minus 2 plus P n minus 1 times an plus Pn minus 2 times the quantity Qn minus 2, n minus 1. And now let's look over here. So I have a an Qn minus 1 and then a Pn minus 1 with a negative sign. And I have the same exact thing over here with a positive sign, so those will cancel out. And I'll just be left with what? I'll just be left with negative Pn minus 1 times Qn minus 2, and then a plus Qn minus 1 times Pn minus 2, which is the negative of Pn minus 1, Qn minus 2, minus Pn minus 2, Qn minus 1. And so I've reduced the index in my original statement over here. I've reduced this index by 1 unit over here. And so I reduced this by 1 unit. And so therefore, what can we say? So therefore, we can say that if I do this n minus 2 more times, then I'll have a negative 1 to the negative 1 from this term. Then I can do negative 1 n minus 2 more times. And so that gives me a negative 1 to the n minus 1. That's our first result. Okay, well, this will come in handy when we do the monotonicity result now. So next, we want to observe the difference between two terms in the convergent sequence. So I have a Cn and a Cn minus 2. I'm going to look at the difference between Cn and Cn minus 2. So these two terms will have the index will have the same parity. This will be Pn over Qn minus Pn minus 2 over Qn minus 2. I'm going to feed in a Pn minus 1 over Qn minus 1 to this. This is going to be Pn over Qn minus Pn minus 1 over Qn minus 1 plus Pn minus 1 over Qn minus 1 minus Pn minus 2 over Qn minus 2. Now we can simplify this. So the first two terms over here are going to be what? Are going to be Pn Qn minus 1 minus Pn minus 1 Qn minus 1. And we know exactly what that's going to give us over here. That's going to give us a negative 1 to the n minus 1. So it's going to be negative 1 to the n minus 1 over Qn and then Qn minus 1. And then I'm going to have a what? Then I'll have a plus, then I'm going to have 1 less than that. So it's going to be negative 1 to the n minus 2 over Qn minus 1, Qn minus 2. And now we can add these expressions together, and we'll have what? We'll have negative 1 to the n minus 1. And then I'm going to need a Qn minus 2 over here. So I have a Qn minus 2. And then I'm going to add that to what? I'm going to add that to a negative 1 to the n minus 2. And then a Qn over here. So a Qn. And now what we're going to do is this is divide by all of them, right? So this is going to be divided by Qn, Qn minus 1, and Qn minus 2. Okay? And so what I'm going to do is I'm going to factor out a, this has the same parity as negative 1 to the n, so I'm going to factor out a negative 1 to the n, and I'll be left with Qn, and then minus Qn minus 2, all over Qn, then Qn minus 1, then Qn minus 2. Okay? Now by my recursion formula, I know what Qn minus Qn minus 2 is. It's going to be an Qn minus 1. So this is really negative 1 to the n. And then we're going to have a what? We're going to have a an And then we're going to have a qn minus 1 over qn minus 1, qn minus 2. So the qn minus 1 is going to cancel out, and you're going to have a negative 1 to the n, an, and then a qn minus 2. Now remember, the an, the qn, and the qn minus 1 are all positive, so the sign of this term is only based on the parity. So if n is even, what can we say? If n is even, then this is going to be greater than 0. So the even terms in the sequence are going to be increasing over here. So we're going to have C0 less than C2 less than C4 less than C6, et cetera, et cetera, et cetera. And the odd terms are going to be decreasing. So we're going to have C1 less than C3 less than C5. It's a less than, greater than sign, so less than C5. Then it's less than, greater than C7, et cetera, et cetera, et cetera, et cetera. So we have an increasing sequence of evens and a decreasing sequence of odds. So in future videos, we'll see how we can use these properties of increasing and decreasing to show that the infinite continued fraction converges. Thank you very much.